All right, starting lesson 7.1, the Pythagorean theorem. All right, the Pythagorean theorem has to do with right triangles. And here we have a right triangle, and the two sides that make up the right angle are known as the legs. All right, now it doesn't matter which leg you call A, which leg you call B. All right, but the legs are always A and B. And for the hypotenuse, the variable associated with its length is C. All right, now there's a relationship among the side lengths of this right triangle. If I take one leg and I square it, and I add it on to the other leg squared, that's equal to the hypotenuse squared. All right, replacing those names with the associated variables, I have A squared plus B squared equals C squared. A couple important ideas with regards to the Pythagorean theorem. The hypotenuse is always opposite of the right angle, and it is the largest length. All right, the hypotenuse is always the largest length, and it is always associated with the variable C. All right, now for example 1, find the missing side length of the right triangle. All right, I have these two legs here. I'll call this A, I'll call that B. This is the hypotenuse, that's C. So I'm going to have 3 squared plus 4 squared equals C squared. So I have 9 plus 16 equals C squared. So 25 is equal to C squared. How do you get rid of the square? I take the square root, both sides. Now, whenever you introduce the square root, you should also include the positive and the negative. But since I'm working with lengths, you can never have a negative length. So that's why I just focus on the positive case alone. So C is equal to 5. Or in this case, it's X. So X is equal to 5. All right, we could have put X here as well. Okay, so for B, here I have a leg, here I have a leg. That's A, that's B, hypotenuse is C. So I'm going to have 2 squared plus 3 squared is equal to X squared. So I have 4 plus 9 is equal to X squared. So I have 13 is equal to X squared. Take the square root of both sides, and X is equal to, well, what's the square root of 13? 13 is prime, so it's just the square root of 13. Done. For part C, here I have the legs. This is A, this is B, and the hypotenuse is C. All right, so now I have 5 squared plus B, which is X squared, and that's equal to the hypotenuse, which is 13 squared. So I have 25 plus X squared is equal to 169. So I subtract 25. X squared is equal to 144. All right, take the square root of both sides. And X is equal to 12. Done. All right, let's do some more examples. Before we do, we're going to learn about a very useful tool. A Pythagorean triple. Our Pythagorean triple is a set of 3 whole numbers, A, B, and C, that satisfy this equation. So for example, the whole numbers 3, 4, and 5, they form a Pythagorean triple, because 3 squared plus 4 squared is equal to 5 squared. So the most common Pythagorean triples you'll see are 3, 4, 5, and 5, 12, 13. All right, now very important, watch for Pythagorean triples in disguise, or multiples of Pythagorean triples. So here I have a Pythagorean triple. Well, how do you know that? If I divide all these numbers by a common divisor, in this case 2, all right, well, what do I have left over? I have 3, 4, and 5. So there's a Pythagorean triple. Same thing with 9, 12, and 15. What's the common divisor? 3. What's left over? 3, 4, 5. For 10, 24, 26, what's the common divisor? 2. What do I have left over? 5, 12, 13. All right, so let's see how useful these Pythagorean triples can be in the following examples. Find the unknown side length of the right triangle by using Pythagorean triples. Well, here I have 3, here I have 4, the hypotenuse must be what? 5. All right. Now, if you forgot the Pythagorean triple, that's okay. You would just do the Pythagorean theorem, go through the steps, and you would still get the same result. But knowing your Pythagorean triples will save you a lot of time. All right, let's do part B. Here I have 5. This is 13. So then this side must be 12. All right, now for C, here I have 6. Here I have 10. What's this going to be? Well, if I divide 6 by 2, what am I left over with? 3. Divide 10 by 2, what am I left over with? 5. Okay, so I'm going to have 2 times some number here. What is that number? Well, look at what I have here. I have 3. I have 5. What's the missing number for the Pythagorean triple? 4. Okay, but I divided by 2, right? Don't forget about that. So don't write x equals 4. A lot of students make that mistake. Okay, it's going to be 2 times 4. So x is equal to 8. All right, watch out for that common error. All right, let's do some more examples. Find the unknown side length of the right triangle. All right, here are the 2 sides that make up the right angle. So that's my A, that's my B, this is my C. So I have x squared plus 6 squared is equal to 8 squared. So I have x squared plus 36 is equal to 64. Subtract 36. I get x squared is equal to 28. I'm going to take the square root of both sides. I'm going to do a little tree here now to break this down. Simplifying the square root of 28, I have 2 times 14, 2 times 7. What do you have a pair of? I have a pair of 2's, so that's the number I pull out. So I have x is equal to 2 square root of 7. Done. All right, for part B, here I have my right triangle. That's my A, that's my B, that's my C. So I'm going to have x squared plus 5 squared is equal to the square root of 47 squared. All right, so I have x squared plus 25 is equal to, what's the square root of 47? Squared, it's 47. I subtract 25, and x squared is equal to 22. Take the square root of both sides, and x is equal to the square root of 22. Nothing else we could do with it. All right, on to the next problem. I have A here for one of the legs, I have B here for the other, and C for the hypotenuse. So I have 7 squared plus square root of 41 squared, which is equal to x squared. So I have 49 is equal to, or I should say 49 plus 41 is equal to x squared. Then I have 90 is equal to x squared. Take the square root of both sides. So let's break down 90. 2 times 45. 3 times 15. And 3 times 5. All right, got a pair of 3's. All right, so x is equal to 3 square root of what? 10. Done. All right, a couple more examples here. Find the value of x. Let's see here. I have this side. I don't know what this length is yet. In order to figure out x, I need to figure out what this length is. Okay, well, I have this small right triangle here. One of the legs is 3. The hypotenuse is 5. So the other leg must be what? 4. Just applying Pythagorean triples there. You could have used the Pythagorean theorem as well. Using the triples saves you a lot of time. So if that's 4, then this section here must be 7. Now I'm going to use the Pythagorean theorem on this triangle. So I have 3 squared plus 7 squared is equal to x squared. So I have 9 plus 49 is equal to x squared. And I have 58 is equal to x squared. Take the square root of both sides. Let's break this down. 2 times 29. 29 is a prime, so there's nothing else you could do. X is equal to the square root of 58. All right, part B. I have x. I have this tick mark here, so this must be x as well. I have this right triangle embedded in the square. Okay, so this is my A, this is my B, and this is my C. So I'm going to have x squared plus x squared is equal to 3 square root of 2 squared. Okay, a lot of little details you have to be careful with here. X squared plus x squared is 2x squared. And 3 square root of 2 squared is what? Well, I'm squaring both of these pieces here. So 3 squared is 9, and square root of 2 squared is 2. So I have 2x squared is equal to 18. Now I divide by 2. X squared is equal to 9. Take the square root of both sides, and x is equal to 3. Done. All right, last couple of examples here. Find the area of the figure. All right, we need to find the area. So I need a base times height. That's the area for a triangle. Divided by 2. Okay, so I'm going to use the Pythagorean theorem to solve for the base, which is a in this case. So I have a squared plus the square root of 21 squared is equal to 11 squared. Then I have a squared plus 21 is equal to 121. Subtract 21. A squared is equal to 100. Take the square root of both sides, and a is equal to 10. Okay. So the base is 10. Figuring out the area now, I have base, which is 10. The height is the square root of 21, and I'm dividing by 2. So I just divide the 10 by 2, and I have 5 square root of 21 as my area. That's going to be meters squared. Done. All right, for part B, I have the base of this triangle. I need to figure out the height. Okay, well, the triangle is split. They should have had a right angle here. Okay, and because that's the only way you could figure this out. That's a right angle there, and so it's splitting it in half, and this is going to be 6 here. All right, and I have this right triangle that I'm working with. All right, now you could use Pythagorean theorem to figure out the height, but if I divide these parts by 2, I have 2 times 5 here. Here I have 2 times 3. So here I'm going to have 2 times what number then? It's going to be 4, because I have 3, 4, and 5. Now, make sure you don't use 4 as the height. Your height will be 8. Okay, so be careful with that. So I have the area of the triangle is base times height divided by 2. The base is 12. Make sure you use the whole thing. The height is 8. And I'm dividing by 2. 12 divided by 2 is 6. 6 times 8. So the area is 48 inches squared. Done. All right, example 6, the final example. The figure below is a cube, all right, 3-dimensional figure, with side lengths 5 units. Find FC and FD. All right, so that's 5, that's 5. It's a cube, so you have right angles all around. All right, so I'm drawing a right angle in 3 dimensions here. All right, so we're focusing right here on this triangle. And then I have the green FC here that I'm trying to figure out. All right, well, this is my A, this is my B, and this is my C. All right, so we're going to have 5 squared plus 5 squared is equal to C squared. So I have 25 plus 25 is equal to C squared, 50. Or actually, instead of calling it C, I'm going to call it FC. There we go. All right, FC squared. All right, now I take the square root of both sides. And breaking this down, I have 2 times 25, 5 and 5. I have a pair of 5s, so FC is equal to 5 square root of 2. Done. All right, then for FD, let's figure out FD. Here I have FD. It's going across the cube. All right, if you can't visualize that, then just let me know, and I'll help explain it to you. I'll have some objects that I could show you that'll help bring this idea to life in your mind. Okay, I'll help you visualize what's going on here. So let's see, what am I going to work with now? I have this length here, which is 5. All right, check it out. I have this triangle here going across the cube. If you can visualize that, just based off of the picture alone. All right, so I have, this is my A now. Let me use red letters. This is my A. This is going to be my B now. Okay, and C is that diagonal going across. That's your FD. All right, so you have to be very careful. My A is 5. What's my B in this case? My B now is what I just figured out before, which is FC, which is 5 square root of 2. Don't forget to square it, and that's equal to FD squared. All right, so I have 25 plus, it's going to be 25 times 2. Don't forget to square both parts. Then I have FD squared. So now I have 25 plus 50 is equal to FD squared. Now I have 75 is equal to FD squared. Take the square root of both sides. I have 3 times 25 and 5 and 5. All right, so I have FD is equal to 5 square root of 3. Done. All right, so the diagonal for the square is 5 square root of 2. The diagonal for the cube is 5 square root of 3. All right, so this is the more challenging problem. It's three-dimensional, so maybe a little hard to see what's going on in your mind. But once again, just let me know if you need help with this, and I'll bring over an object to you and help explain it to you so you can help visualize it better. All right, if you have any questions, make sure to ask. Begin the assignment.